So this above equation will give the maximum power which is dissipated by any active device. So whenever you are going to use a transistor as an amplifier, you have three terminals and each terminal will have amount of loss. So you cannot escape from that. So when there is no AC signal applied, the output AC power is zero. So only you have power loss because of the DC component. So the PDV will be maximum value of VC into IC. When you are going to apply an input signal, the heating of the cycle device is reduced because you have positive and negative half cycle alternating in the input side. The positive half cycle will be the power will be dissipated. The negative half cycle, the power will be absorbed. So alternatively, this takes place. So when there is input signal, the power loss is less. When there is no input signal, only power loss will dominate your device. So hence the amplifying device is cooler when delivering power to the load than when there is no such power transfer. So when you are giving an AC signal, the amplifier is considered to be relatively stable because the losses are going to be minimal in nature. So the conversion efficiency, this is the measure of the efficiency of amplifiers. The conversion efficiency is given by this formula eta. Eta equal to, simply it is PAC by PDC. Output AC power divided by input DC power. PAC by PDC. And you know PAC is VRMS into IRMS divided by DC power is VCC into IC. And VRMS, you know, VM by root 2. IRMS is IM by root 2 divided by VCC into IC. So VRMS into VM into IM by 2 in VCC IC into 50 percentage, or I can write 50 100 percentage. So it 50 this 2 over 100 will become 50. So it is 50 into VM IM divided by VCC into IC. This is the expression for conversion efficiency of your class A power amplifier. So conversion efficiency is defined as the ability of the active device to effectively convert your DC power into AC power. So it is a theoretical efficiency denoted by eta, and the expression is given here. It is just literally PAC by PDC. Input biasing you give, and what is the output AC power I get because of amplification happening inside the device. So this efficiency is overall it represents the collector efficiency because you take the output from the collector. So we have not taken any loss which is happening in the base side of your transistor. Okay, so if you consider everything, then the efficiency will even more reduce. So without certain ideal expressions, we found out the efficiency. If we consider all factors of base power loss, emitter power loss, when you consider everything, then you will definitely find that the efficiency value will be slightly lesser than whatever theoretical value you have got. Okay, so efficiency, it is, you know that in a class A amplifier the Q point is exactly in the middle. So that is the reason why you get highly linear operation of your input. So the Q point is exactly in the middle of the load line. So it is equidistant on either side. So on the Q point is the reference zero value, and above the Q point, the peak one is I max, below it is I minimum. Same way in the x-axis you see the reference value is VC, the minimum value is V minimum, the maximum value is V maximum. Okay, so this is the output graph we consider. So the static, we see that the Q point is equally spaced on both sides. That makes our simplification very, very simple. So under ideal conditions, your VCC will be Vmax. So the maximum, the output voltage will be equal to VCC, and the minimum output voltage will be equal to 0. So under ideal conditions, the maximum output voltage will be equal to VCC, and the minimum output voltage will be equal to 0. Okay, see the V minimum is close to 0. So I can write Vm equal to Vmax minus Vmin by 2. You know, Im equal to Imax minus Imin by 2. So Vmax will be equal to VCC. Vmax is VCC. V minimum is 0. Imax is going to be equal to IC. So if you do all these simplification, and your efficiency expression becomes eta equal to 25 into Vmax minus Vmin by Vcc. But Vmax is Vcc, V minimum is 0. So Vmax minus V minimum will become Vcc. So it is Vcc by Vcc will get cancelled. So the efficiency will be 25%. Okay, the efficiency will be 25% for a normal case, for a directly fed class A power amplifier. Okay, if you are going to have a transformer fed power amplifier, then the efficiency formula will change. You have to use this formula, 50 into Vmax minus Vmin by Vmax plus Vmin. Always remember Vmax is Vcc and V minimum is 0. So when you substitute this values, 50 into VCC minus 0 by VCC plus 0, so 50 into VCC by VCC, you get the efficiency as 50%. So when you are going to use transformer coupled amplifier, the efficiency is 50%. When you use normal amplifier, direct fed, resistance fed amplifier, the efficiency is 25%. So this is the conditions we have for class A amplifier. So the efficiency value is going to be very, very high if you are going to use a transformer coupling between the output stage and the load resistors. Okay.